When we think of storms, we usually imagine swirling blobs that look something like this. But if you've ever looked at Saturn's North Pole, you may have noticed something strange. There's a massive hexagon that has remained there for decades. And while we think of it as a surface phenomenon, some new research suggests that it extends hundreds of kilometers deep into Saturn's atmosphere. So how does such a stable structure exist in all that turbulent gas? Let's dive in. The North Pole of Saturn has been observed since 1850, when an amateur astronomer first noticed it during a time when telescopes were just becoming more widely available to hobbyists. In the years since, we've seen it again and again, but only really got our first good look at it thanks to Voyager in 1980. What we saw was a giant hexagon about 20,000 kilometers wide, with each side roughly the length of one of Earth's longest rivers, the Nile. What we didn't see was anything else. It looked like a hole had been punched out of the planet's atmosphere. But is it a hole or just the top of a very deep storm? Back in the day, scientists thought it was just a surface feature because back then they assumed that's all it was, just a regular old jet stream. You see, here on Earth, we have jet streams that blow us and our weather systems across the planet. They're narrow bands of high-speed wind that form around 10 kilometers above our heads. These fast-moving rivers of air help steer weather patterns like hurricanes and also smaller-scale ones like thunderstorms. On Saturn, we see these same features, except there's no round about it, a flat-out hexagon. And this one isn't your average jet stream either. It's bigger than any similar storm on Earth, and it has lasted for at least 30 years. We know that because in 2010, Cassini made this remarkable discovery, showing that the hexagon was still there 30 years after Voyager snapped its photo. The best part, it looks exactly the same. If you take a look at the two images side by side, you can see that every point and indentation lines up almost perfectly. So what keeps this thing stable? The winds within it blow at over 600 meters per second, which is faster than the orbital speed of many moons of Saturn. And if this much energy is being put into maintaining this storm, then clearly there's some serious stuff going on here. For a long time, scientists struggled to answer these questions because they could only observe the top of it. But now they think they've solved the mystery, thanks to this image taken by Cassini in 2017. This is the first time we've seen below the top layer of the hexagon. And it appears that the storm doesn't end at the top of Saturn's atmosphere. It extends down through hundreds of kilometers of gas. Scientists are still working on analyzing this image and future images, but they already have a few ideas about what might be happening here. First, let's talk about why this discovery was even possible. Remember, this is Saturn. The planet itself is mostly gas. It doesn't have a solid surface. Instead, there's just one layer of atmosphere after another, getting denser and hotter until eventually you hit the metallic liquid core. Because there's no solid ground, storms on Saturn can get pretty big. And it's hard for them to stop once they start. Cassini came along to measure these storms and find out what fuels them. It carried a radar system that could beam radio waves down through the tops of Saturn's clouds and bounce the signal back off the bottom of the atmosphere. This way, Cassini could map what's going on under those clouds without needing to land on the planet. But here's the problem. Scientists couldn't tell exactly where the bottom of the atmosphere was. As the signal bounced through the clouds, it would hit different layers of haze and get reflected at different times. So scientists didn't know whether they were seeing the bottom of the atmosphere or just another cloud layer. But then in 2017, they took this picture. This time, instead of bouncing radar signals through the atmosphere, Cassini aimed its camera upwards and peered through the top of the hexagon. In this image, bright spots represent clouds. And in order to see through the hexagon, Cassini needed to look above a huge wall of clouds. It was able to do that because Saturn's North Pole has a unique atmospheric condition that lets light pass straight through some parts of the atmosphere. That's why we can see inside the hexagon for hundreds of kilometers. This image gave scientists their first look at what's below the top of the hexagon, and it looks like a storm cell. In fact, it looks a lot like the top of a thunderstorm on Earth, which may mean that Saturn's hexagon is actually more like a thunderstorm than a jet stream. That makes sense considering that Saturn's hexagon shares a lot of similarities with thunderstorms. Both are highly dynamic vortices of awfulness. They both last for decades, and they both maintain themselves against the forces that would normally tear them apart. In the case of a thunderstorm, that's updrafts and downdrafts of air. Hot water vapor gets lifted up from Earth's surface. As it rises, it cools, which forms clouds and also causes even more vapor to get sucked up, and it gets stronger until bam, thunderstorm. Now, Saturn's hexagon doesn't seem to have updrafts or downdrafts like a traditional thunderstorm, but it does have something else, shear. On Earth, shear happens when two different kinds of air meet and the faster-moving air pushes the slower air out of its path. This is what happens when a fast-moving storm front passes through town. Shear can also happen when two different air currents move past each other, like when a jet flies through a patch of wind. In both cases, shear creates turbulence, which can cause less stable structures like tornadoes to break apart. But it can also play a role in making larger structures more stable. If there is a fast-moving current of air far above the hexagon and a slower current of air below it, that could create enough shear to keep it stable, and it could explain why it lasts so long. So in the end, Saturn's hexagon may not be the jet stream we thought it was. But whatever it is, it's yet another example of how strange and amazing Saturn is. It's also a great reminder of how little we understand the universe. We can study Saturn for decades and still learn something new about it. That's why I'm so excited about the future of space exploration. Thank you for watching this SCI Show Space video. And thank you to our President of Science. Your generous support makes it possible for us to bring mind-blowing space content to everyone for free.